Hi class step, let's continue our class and today we'll finish the chapter. Okay. So today we'll discuss or we'll read on page number 157. There we have torque. Today's topic is your torque on a current loop. Okay, so write down torque on current loop. Okay, or magnetic dipole also written is there. Okay, magnetic dipole. See, torque on a current loop placed in a magnetic field. Okay, next topic is here torque on a rectangular current loop in a uniform magnetic field. Okay. So let's see, here we know if a current is there flowing, then there is a magnetic dipole, isn't it? So magnetic dipole M equals to how much? I into A, isn't it? The current flowing through the circuit and the area, isn't it? So the direction of magnetic dipole moment is how much? See, thumb and cord finger and thumb will be direction of your thumb will give direction of magnetic dipole moment, isn't it? So here inward, isn't it? Right. So we know this one, isn't it? And also we also know that this is your current, then there is magnetic field, then current is flowing, then it experiences a force equals to how much? The current, the magnetic field into the length, current length, isn't it? F equals to I BL. We know this too, isn't it? On this basis we'll understand this torque. Okay. So first let us see. First case is here when two case we have to do in this. Okay, so when first case when angle between magnetic field and magnetic dipole is 0. Okay, so at that time what happens, isn't it? So this is our rectangular loop, isn't it? Rectangular loop. Clear? So current is flowing like this. Clear? And this is your B. If I take this side as a B and this side as A. Okay, so in a uniform magnetic field, isn't it? So these are the magnetic field. Okay, direction of magnetic field. Clear? So this is the direction of magnetic field inward, isn't it? And here we have direction of magnetic dipole moment. So direction of M equals to, see, current and this, so also inward, isn't it? Magnetic dipole moment. Clear? At this time, so net force F net equals to how much? You'll get 0. Why? Because this sum gets force equals to how much? F equals to I, this is B and B sine theta, isn't it? Again this is your magnetic force, so F equals to I B B, isn't it? So they are equal and opposite, so they cancel each other. Okay, and here also you'll get, isn't it, F equals to how much? I B A. Why we are using length as A, isn't it? Length as B. So here also equal and opposite, they cancel each other. Okay, so there is no torque, so torque also, net torque also 0. Clear? Understood? Now second case we have to change this one. Okay, angle between M and B, see, we have to understand. Okay, is theta. Okay, So if you change this, okay, by theta, or you have to rotate this, your what you call a rectangular current carrying loop, rotate by some angle, then there is a torque. Okay, net force always 0 हुन्छ, यो याद गर्नु. ओके, तर के हुन्छ, टर्क लाग्छ. ओके, यति बेला के हुँदैछ हेर्नु. दिस इज आवर रेक्टेङ्गुलर, 10 मा पनि गरेको इज नि ट्रान्सफर्मर, सरी इलेक्ट्रिक मोटर इज नि, यस मोटरमा गरेको. अब के हुँदैछ, यताबाट पनि फोर्स लाग्दैछ, यता थेल्दैछ, यता पनि. सो इट विल नट मुभ. ओके, ऊबाट पनि थेल्दैछ, तान्दैछ. ओके, के गर्दैछ, यसलाई पुल गर्दैछ, दुईपट्टिबाट पुल. इट विल नट मुभ. ओके, so if I change the direction of this magnetic field and the magnetic dipole moment, so this, if you change this, then some angle is there, isn't it? So initially we have so initially we have this type of current carrying loop. Okay, now we are changing the theta angle between the magnetic field and current carrying loop. Okay, so change this one. So we are rotating the rectangular by some theta angle. Okay, theta angle, clear? This is all again B, this is A, and magnetic field is going like this, inward, and magnetic moment, now direction of magnetic moment changes in it. Why? Now I am changing, same magnetic field is coming. Okay, so but theta angle rotated, isn't it? So your magnetic field and magnetic dipole moment have some angle. Okay, so this is your magnetic field moment. Okay, and this is your magnetic field, right? जान्दैछ एकछिन इनवर्ड. तर अब के हुँदैछ, म्याग्नेटिक डाइपोल मुभमेन्ट चाहिँ के छ, चेन्ज भएको छ एकछिन, अर म्याग्नेटिक मुभमेन्ट. सो दिस एङ्गल्स चेन्जेस, इजन्ट इट? सो के हुँदैछ, अब फोर्स यता लाग्दैछ, एउटा कता लाग्दैछ, यस्तो लाग्दैछ, भन्नु मतलब ट्विस्ट भएको भएन. सो यति बेला चाहिँ के हुन्छ, फोर्स एउटा यता लाग्दैछ. सो लाइन अफ एक्सन इज डिफ्रेन्ट. अघि के थियो, लाइन अफ एक्सन सेम थियो थिएन, लाइन अफ एक्सन भन्नु सेम मिन्स यताबाट पुल गर्दैछ होइन. अब चाहिँ के हुँदैछ, लाइन अफ एक्सन डिफ्रेन्ट हुँदैछ. सो के हुँदैछ, यो यता लाग्दैछ, यो यता लाग्दैछ. सो इट विल टर्न. कुरा बुझ्यो? सो हियर अगेन फोर्स, नेट फोर्स how much, 0. That means this will cancel this and this will cancel this, equal in magnitude, opposite in direction. But torque is not equals to 0. Torque, net torque is not equals to 0. Why? Because line of action of force are not same. Okay, different, isn't it? Clear? So now it will turn or rotate. So that rotational motion is called torque, isn't it? so net torque is how much? Net force is always 0. Okay, when magnetic dipole is placed in a magnetic field. So torque is like this, isn't it? Torque, net torque equals to how much? एउटा यता लाग्दैछ, isn't it? Now direction is changed, isn't it? Sorry, line of action is changed, isn't it? So I छड्के बनाऊ. So this is your F1. If I say this is your F2, these two are cancel each other. Why? Because their line of action is same again, right? So there is a torque, isn't it? So now now तिम्रो बुकमा लेखिदिएको छ टप भ्यू, isn't it? Okay, so top view हेर, isn't it? So this is your top view, माथिबाट हेर. So के हुँदैछ, this is your initial point, initial, isn't it? पहिला कति थियो, यतिको थियो. Now you have changed the by theta angle, isn't it? You turn the rectangular loop into theta angle, isn't it? So what happens if this hole is A? So this is your A by 2, this is your A by 2, isn't it? Yes sir. And this is your perpendicular, isn't it? Right. So this is your F1 and this is your F2. So you have to add this to, isn't it? Torque equals to how much? So also you have to know torque equals to, here write down, torque equals to force into perpendicular distance, right? Perpendicular distance. तिम्रो बुकमा मजाले लेखिदिएको छ, okay? So force into perpendicular distance. So this is your cos and this is your how much? A by 2 sin theta, isn't it? Perpendicular. This is also A by 2 sin theta, isn't it? So net torque equals to F1, okay, F1 A by 2 sin theta, isn't it? Sin theta plus F2 A by 2 sin theta. Book ma मजाले लेखिदिएको छ, okay? So now do it. So this is how much? F1 and F2, you know, isn't it? Yes sir. Sin theta is common, so got it. Torque, net torque, okay, equals to F1 how much? See, F1 I B, isn't it? B into A by 2 sin theta plus next one is your F2 I again B into A by 2 sin theta, isn't it? F equals to how much? Current, magnetic field and the length, isn't it? Clear? So now take the common. Sin theta is common, I also common, B also common and B also common. So A by 2 A, isn't it? So sin theta, right? So this is your how much? Equals to I is your current, okay? So now write down I B into A, area of cross section, B sin theta, right? So IBA sin theta, isn't it? So this is also you can write IA, you can write magnetic moment, isn't it? So M B sin theta, clear? So also you can write torque equals to net torque equals to M cross by. This is sin, isn't it? Sin theta. So cross is there, isn't it? 11 number correction. So likewise in your electrostatics you have torque, isn't it? In a dipole, isn't it? What is that? How much is that? Torque equals to how much? Torque electricity equals to PE into E, isn't it? Cross E, not into, cross E. So sometimes they may say if there is n turns of coil, n turns of coil are there, so you just multiply it by torque net equals to torque net equals to, if n turns is there then n E n I A B sin theta, okay? And I again you have NIA, you have M, isn't it? So you leave it again M cross B, clear? So now your homework is example 4.11, okay? Okay, this one. Then 4.12 is your homework. Then these are done, isn't it? Circular, magnetic dipole, electric dipole, movement of revolving electron. Electron come gora, okay? So this is very simple. So now write down moving coil galvanometer, okay? Very important topic. So मजाले हेर, okay? Then you'll understand. So write down next topic, moving coil galvanometer. Okay. So this moving coil galvanometer is based on this one, isn't it? Torque. Whenever there is current carrying conductor in a uniform magnetic field चाहिँ कस्तो हुनु पर्यो, uniform, it experience a torque. Okay, so that means it turns. Okay, so write down moving coil galvanometer. So moving coil galvanometer. See, so many scientists was there, and they made an instrument, okay, that detect or that measures the current, okay, through any circuit. And so write down what is galvanometer. So you just write down, it is a device uh, used to measure or detect small current. You should write down small current. Yeah. So galvanometer is a device used to measure or detect small current. ठुलो करेन्टले मेजर गर्दैन. ओके, कतिसम्म गर्छ भने मिली एम्पियर. 1 एम्पियर पनि इट क्यानट मेजर. ओके, द ग्याल्भेनोमिटर कति हुन्छ, मिली एम्पियर. तिम्रोमा हुन्छ ग्याल्भेनोमिटर यस्तो परेको बक्स छ कि ल्याबमा. सो देयर लास्ट रिडिङ कति हुन्छ, 30 मिली एम्पियर. ओके, 0 देखि. राइट. सो द्याट इज योर ग्याल्भेनोमिटर. नाउ राइट अन प्रिन्सिपल. Principle, just write this one. अगाडि पढेको थियौँ, torque on a current loop in a uniform magnetic field. So principle, on which principle it does the work. Okay, so write down principle. It works on the principle of torque on current carrying loop in magnetic field, in uniform, right down, uniform magnetic field. Okay, so they have like this pole and okay, diagram दिएको छ. Okay, galvanometer मजाले गर. Okay, पढ, बुझिहाल्छ. Okay, just read. So torque is there, isn't it? So how it torque equals to how much, NIAP, isn't it? Torque, net torque. So this deflection phi is your deflection of the coil. यिनीहरु attach हुन्छ. Okay, needle attach हुन्छ. So it will turn. Okay, जति current pass भयो त्यति यो turn हुन्छ. Okay, त्यति यो घुम्छ, घुम्दैन. So phi is directly proportional with torque. This is the principle of galvanometer. Sorry, this is how it works. Okay, so phi is your deflection or measurement of current. So equals to almost some constant into torque. So this equals to almost phi equals to some constant, torque means NEBI. So this is your some constant K. Okay, so you can use I. So K is here. Okay, into I. So next just गर यहाँ पढ. ओके, पर युनिट. ओके, मजाले बनाइदिएको छ यहाँनिर. एमिटर कसरी बनाउँछ, सन्ट रेजिस्टेन्स लाएर बनाउँछ. यसलाई रेजिस्टेन्स बढाएर यसलाई के बनाउँछ, ग्याल्भेनोमिटरलाई के बनाउँछ, एमिटर बनाउँछ. फेरि ग्याल्भेनोमिटरलाई नि फेरि रेजिस्टेन्स अझै अर्को रेजिस्टेन्सले के बनाउँछ, भोल्ट मिटर. ओके, वाइ, बिकज ग्याल्भेनोमिटर cannot resist big current. Okay, it only resists small current. It measures small current. Okay, high current it does not resist. Okay, So मजाले पढी. This is and question number sorry example 4.13 गर. ओके अरु त सबै गरेको छ. ओके सो 4.12 these are your homework and you can do this one exercise also. Okay, so next we'll do next chapter from next class. Okay, by this week. Next chapter is very what you call short. Then we yes. So thank you class this much for today. Stay home, stay safe.